Most students can find the area under one curve, but the moment there are two curves, things get confusing. Here's the truth. You're still finding area, just subtracting one curve from another. Master one simple rule, and you can solve these in seconds. Everything comes down to one formula. The area bounded by two curves will be equal to the integral from a to b of the top function minus the bottom function with respect to its variable. So first, you want to identify the top function. That is, which function has greater y values on the interval. And then identify the bottom function. Which function has smaller y values on the interval. Then you subtract. You'll form the integrand and do top function minus bottom function, and you'll integrate and evaluate over the given interval from a to b. For example, if we want to find the area between y equals x and y equals x squared on the interval from 0 to 1. In blue we have the curve y equals x squared, and in red we have the line y equals x. So we can clearly see that the top function is x and the bottom function is x squared. So we can set up our integral as integral from 0 to 1 of x minus x squared, because x is the top function and x squared is the bottom function. With respect to x, that is dx. Finding the antiderivative, that will be equal to x squared over 2 minus x cubed over 3. And we'll evaluate that from 0 to 1. So first we plug in x equals 1 into our antiderivative. That will be equal to 1 squared over 2 minus 1 cubed over 3, which is 1/2 minus 1/3. Minus, we need to evaluate when x equals 0. That will be 0 squared over 2 minus 0 cubed over 3, so that is simply 0. So 1/2 minus 1/3 is equal to 1 over 6. So that is the area bounded by the two curves y equals x and y equals x squared on the interval from 0 to 1. Now, what if we want to find the area between y equals x squared and y equals 2 on the interval from 0 to square root of 2? If you don't have the graph, you can simply plug in a number on the interval into both functions in order to see which function has greater y values on that interval. In this case, x squared will always be less than 2 on the interval from 0 to square root of 2. Therefore, the top function is y equals 2 and the bottom function is x squared. So we can set up our integral as integral from 0 to square root of 2 of 2 minus x squared dx. That will be equal to 2x minus x cubed over 3, and we'll evaluate that from 0 to square root of 2. So first, if we plug in square root of 2 into our antiderivative, that will be equal to 2 times square root of 2, which is what we have here, minus square root of 2 cubed over 3. And then we plug in when x equals 0, that will be 2 times 0 minus 0 cubed over 3, which is 0. So then we can simplify this as 2 square root of 2 minus 2 square root of 2 over 3. And in order to subtract fractions, we need a common denominator. So if we multiply 2 square root of 2 by 3 over 3, that will become 6 times square root of 2 over 3 minus 2 square root of 2 over 3. And now we can subtract, and that will be 4 square root of 2 over 3. In other words, the area bounded by x squared and y equals 2 on the interval from 0 to square root of 2 is 4 square root of 2 over 3. In this next example, we want to find the area between y equals x squared and y equals 2x. No interval is given, so in this case we must find the bounds first, or in other words, we must find the points of intersection. So here I have graphed the two functions. In blue we have y equals x squared, and in red we have y equals 2x. We can see from the graph the points of intersection, but let's solve it algebraically. So in order to solve, we need to set the two functions to be equal. So if x squared is equal to 2x, if we subtract 2x from both sides, we can rewrite this as x times x minus 2 and set it to be equal to 0. Solving for x, either x equals 0, because if you have 0 times 0 minus 2, that will be 0. Or if we set x minus 2 be equal to 0, x will be equal to 2. So we can see I have a point of intersection here at x equals 0 and another one at x equals 2. Now we can set up our integral. The top function is 2x, the bottom function is x squared. So that will be equal to integral from 0 to 2, where 0 and 2 are points of intersection, of 2x, the top function, minus x squared, the bottom function, with respect to x. So that will be equal to x squared minus x cubed over 3, that we'll need to evaluate from 0 to 2. When x equals 2, 2 squared is 4, 2 cubed is 8, so 8 over 3. And when x equals 0, well, that would be 0 squared minus 0 cubed over 3, which is 0. So 4 minus 8 thirds will be equal to 4 thirds. So therefore, the area bounded by x squared and 2x on the interval from 0 to 2 is 4 thirds. So here's your challenge for today. Find the area between y equals x plus 1 and y equals x squared. No interval is given to you, so you'll first need to find the points of intersection. In order to do so, you must let x plus 1 be equal to x squared. So let the two functions equal each other and then solve for x. So if you subtract x plus 1 from both sides, that will be x squared minus x minus 1 equals 0. You can solve for x by using the quadratic formula. So x will be equal to 1 plus or minus square root of 5 over 2. So then you can set up your integral. So your limits of integration will be 1 minus square root of 5 over 2 and 1 plus square root of 5 over 2. And you'll need to identify which one is the top function, which one is the bottom function in order to integrate. So remember, when no interval is given, always solve for intersections first to establish your limits of integration. Here's your fast track summary. The area between curves equals the integral of the top function minus the bottom function. Always verify which function has greater y values on the interval before integrating. And when no bounds are given, set the functions equal and solve to find their limits. Master this and you'll solve area between curves problems fast on any exam. Thanks for watching. Please like and subscribe to keep learning with us. And don't forget, math success starts when you stay on the fast track.